So I'm sensing people are done. Frequencies, I think you guys came up with, there are 5 A's, there are 7 B's, there are 8 O's, 9 O's, sorry, 9 O's, and how many AB's? 4. And then there's 25 total if you add them up. So my relative frequencies, what fraction is in each one? So what percent is in our A's? 5 out of 25 are A's. That's my ratio kind of there, right? So 5 out of 25, if I do my math, that's 20%. This one would be 7 out of that, so that would be 28%, 36%, and 16%. You can also do them as decimals. That's totally fine also. I don't care whether you do them as percentages or decimals, but typically people don't do them as fractions, so usually. So do them as one of those other two. Here they are as decimals. Let me get my little thing here. So 0.2, 0.28, 0.36, and 0.18. 16, sorry. That would work also. Okay? Good. Do you guys take 30 seconds with your neighbors? No? Everyone's good to go? All right. You guys are like, let's get out of here. All right. No, perfect. So again, we use group frequency distributions when the range of the data is very large. We split data into equal sized classes. They have to be equally sized, otherwise it's not fair. Right? These have to be the same size as each other. However, sometimes we can be open-ended on the top or the bottom. Right, so the bottom can be this much and above. When would you do an open-ended? Do you guys know what I'm talking about when I say open-ended? See how it's a 70 or more? That's open-ended. Open-ended on the bottom would be, like 25 or less. That would be open-ended on the bottom. But a prime example of a great time to use open-ended would have been when we look at our here we go. Nope. These guys here. See how we kind of have like 5, 6, 7, and that 8 was really supposed to be what?
5.
5 was really supposed to be 5. Okay. You zone out. It's supposed to be 5. So we have 5, and we have, was it 13? Mm-hmm. So this is really 2, and this is really just 1 there. So guys, pay attention. Here's the thing. I go from 7, and then I have, so I have 5 has 2, 6 has 2, 7 has 1, and then I have 8 has 0, 9 has 0, 10 has 0, 11 has 0, 12 has 0. You see what I'm saying? I could just do 8 or more. Do you guys understand what I'm saying? Because we go from here, we kind of jump. We have all these spaces. We could have done 8 or more, or since we only have 1 and 7, we could have done 7 or more either. Also, do everybody kind of follow what we're talking about? Mm-hmm. So because we have kind of this gap here from here to here, we could have just done 8 or more, or 7 or more, and just had those 1 or 2 in that class, and it could have been open-ended on the top. And that's a classic example of a great time to do that. Good. Let's fast forward all the way through. And let's talk about how you decide to split them into groups. Okay, so this is from the textbook. Let's have Philip F. Go ahead and read.
How do you decide how to split them into groups? First, decide how many classes you want. Find your range from the smallest to the largest. Divide this range by the number of classes, and round up to the next integer to see how many values should be in each class. You need to cover the entire range of values, so better not to cover more than your range versus less.
Good. Yeah, perfect. So before we even start on that, let me ask you this. If we read pages 10 to 20, how many pages have you read? If your assignment is read pages 10 to 20. So the instinct is to say 10.
But it's not.
But like someone said, it's really 11. And we can prove that by counting 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. That's 10 pages. 20. That's 11 pages. Why? Because from 10 up to 20, but not including 20, that's 10. But once you include 20, that's one more. So your range, if you're talking from here to here, the range is really that minus that. That's how you find a range. You take the highest and you subtract the lowest. And then to figure out how many there are, you have to add 1 to that, to whatever that is. So really, so the range is 10 to 20, but this is really 10 plus 1, your range plus 1. That's 9 pages are right there. All right, so let's take a look at an example. I have a bunch of rats. I weigh them all. Doesn't matter how many rats I weigh. It just matters what ranges I need to cover. So the skinniest rat is 8 ounces. The biggest rat is 20 ounces. What's my range? So again, it doesn't matter how many rats I have. I need to cover anywhere from like 8 ounces to 20 ounces. So my range. So remember, range is the largest minus the smallest. So that's 20 minus 8. So my range is 12, but I really have 13 items, right? How many classes do we want? Well, typically we go, you have to have at least 5, no more than 20. You could have 1 for each one. Let's go with like, say, let's try for 6 and see what we get. Okay, so let's try 6. Because 6 is kind of an easy thing to wrap our heads around. And see what we do there. So I have my 12, and I'm going to add 1. Or, let's see, how does your book do it? I think your book just takes the range divided by the number of classes. So the book would just do 12 divided by 6, and we get 2. Here's the thing: I can't leave a class width of 2 and have 6 classes, because I would run out of space for the last class to be. Here's what I mean. So my first class would be 8 to 9. That has a class width of 2, 8, and 9. Those are the 2 things in that class. So that's a class width of 2. Does everybody understand what I'm saying? So class width of 2 means you have 2 objects in it. I have 8 in it and I have 9 in it. I've got two spots. So the next one would be 10 and 11. That would also have 2 in it. So class width of 2.
Oh, I
So these are all class width of 2. They all have 2 items in it. They go from one to the other one. So this would be 6 classes. I'd have nowhere for 20 to go. So that's why you always have to round up. Do you understand what I'm saying? If I was locked into 6 classes, then I'd have to make this. I'd have to round up from 2 to 3. But in reality, what would I do instead? What else could I do? I need to cover 20. What would I do? Yeah.
18 and above.
I could do 18 and above. That's a thought. I could totally do that. Or I could just add another class. Right? If I wasn't fixed on 6 classes, I could just make it 7 classes. And I would go 20 to 21 and have 7 classes. So it's kind of another way you can do it. This only comes up when you have a really small range, like a range of like less than 20, less than 25. Yeah,
Maybe I missed it. Why did you use the number 6?
I just picked an arbitrary number of classes.
Okay.
Yeah, could have picked 7, could have picked a different number. 13 seems like a lot. I don't know that I'd go 13. I'd probably go something, I'd probably put a class width of 2. It's an optional thing. But this is how the book teaches it. It's only going to come into effect when you have a small range. If your range is 25 or more, we're going to do something a little bit cleaner. So this is what happened. That's what I used to do the first 2 years I taught this class. I just did what the book said, which your textbook said to do, and I taught it that way. But then I argued with my friend Jim Hannon. He's a real statistician. He was a statistics guy, the statistics guy, kind of almost, at Lawrence Livermore Lab for many, many, many years, a couple decades at least. And he said that really the whole purpose of making a frequent distribution is to show your data, to try to prove a point. You're going somewhere and you're trying to sell your idea or make your point to a group of people. And the whole point of this distribution data is to clearly show your data, make them understand it. So having all these weird numbers is not so useful. So pretty much what you want to do, if you have a small range like what we did last time, then kind of what we did was okay. But really, if your range is like 45 or more, or at least, or even 25 or more, then what you really want to do is have class widths of like 5 or class widths of 10, right? Like if I have 45 data values, and you had a range of 45 in there, I might go like 10 to 19, 20 to 29, 30 to 39, 40 to 49, and people can wrap their head around that better, right? So that's kind of, that makes a lot more sense. So we argued, right? I was like, but the book says this. He's like, well, no one does that. And I was like, well, yeah, but the book says this, right? So we kind of went back and forth for a year and a half, and then he won. I was like, you know what? You're right. That makes more sense. So I've switched over to doing that. And that's what you should do with your friends, right? If you disagree on something, argue until one of you wins. And then you come with like the best answer because you've thought it through, right? You've kind of made all the arguments and you've kind of really wrapped your head around it. All right, so we're going to see more of that later on. Actually, we'll probably see that next class is a good example of why you should do that instead. First, let's discuss the parts of a frequency table. So in the copy example, we split data into 6 classes. You guys remember that? We just did it. We had lower and upper limits. So these guys are our lower limits. They are the lowest possible value that could be in that class. These are the lower limits. And likewise, these are the upper limits over here. In other words, the largest I can be and still be in this class is 304. The smallest I can be and be in this class is 244. Right? That makes sense. If someone said 244, they'd be in this class. But if someone said 243, then they would automatically go to that class. So these are the upper and lower limits that you can be to still be in that class. Those are actual data values in that class. Boundaries, similar to what we talked about last class. You guys remember those? Class boundaries separate the classes. So to find a class boundary, you take the upper limit from the lower class and the lower limit from the next class, and you average those two numbers. So this is the first class, 0 to 60. This is the second class, 61 to 121. Third class, 122 to 182. I want to find the boundary between these two. So I'm going to take his upper limit and his lower limit, and I'm going to average them to find the boundary between them. So 60 and 61, if you average 60 and 61, what do you get? 60.5. That's the number smack dab between these two numbers. Right? You average those two, you get the number smack dab between them. That's the number between this class and that class. His upper boundary, his lower boundary. Make sense? Same boundary. Okay. And then what's the boundary between these two? 121.5. Oops. So that's his, so 60.5 is his lower boundary and 121 is his upper boundary. That's the same, again, his upper boundary is the same as his lower boundary. It's the same boundary, right? And then his upper boundary is his lower boundary, 162.5. What's his upper boundary? 243.5, which is the same as his lower boundary. And then the upper boundary here would be 304.5, which is also his lower boundary. And then here you can either say 365.5, or you could say, well, you can't have more than 365 days, you could have left it at that. All right, so, but those are the boundaries. They separate the classes. So this is the one that separates this class from that class. This number is the number that separates this class from that class. It's the boundary between them. Do you guys need 30 seconds with your neighbors for this? You sure? Okay. If you are, just give me a little nod, and I'll give you some. Okay. Now, this is interesting. If you already have a frequency distribution, in other words, it's already been made for you. You didn't make it. I made it. You can find the class width by subtracting successive lower class limits or boundaries, or successive upper class limits or boundaries, or upper lower boundaries. Let me show you what I mean. So here, my upper boundaries, actually I'll do it like this. So let's just look at the lower boundaries. How far apart are they?
60.
0 to 61.
60.
Well, and how far apart is 61 from 122? How far apart are these guys? 61 to 0. How far apart is that? Subtract them. 61 minus 0, what is it? 61. How far is 61 to 122 if you subtract them? How much would you?
61.
61. So these are all separated by 61. How about these guys? What are they separated by? 121 minus 60.
61.
61. These guys? 61. What's my class width? 61. How do I know that? Because 0 to 60, 1 to 60 is 60. Right? If you have one person is 60, you start with number 1, count off. You're number 1, 2, 3, 4, up to 60. You'd have 60 people. And then don't forget Mr. 0, the 0th person. He's another one. So then you actually have 61 people. You know what I'm saying? So now, if you numbered people, you gave them jerseys. You're number 1 up to 60. You'd have 60 people. And then you add another guy and you give him the number 0 jersey. Then you'd have 61 people. So yeah, there's 61 people in each of these classes. There's 61 spots in each one of those classes. That's the easiest way of finding your class width. If you aren't making this, it's already been made. Someone else has made it, and you're just trying to figure out what class width they used. Right, so this is the opposite. You're not making it. You're looking at someone else's that has already been made, and you're trying to figure out what their class width is. Everybody follow that? Okay. Now, midpoints can be calculated by averaging the upper and lower class limits, or the boundaries. So if I see where it says mid here, midpoint, anytime you have something mid-range, midpoint, that means you're going to be averaging two items, the largest and the smallest. So midpoint, you're going to take the largest and the smallest, and you're going to average them. So 61 and 121, everybody average those numbers. Add them up and divide by 2, right? There's 2 of them. What do you get?
91.
91. So the midpoint is 61 plus 121 divided by 2, 91. This one here would be, how did I find this one? 122 plus 182 divided by 2,
102.
152? 152. Good. And what did I say my class width was for these guys? 61. How far apart are these? 61. So if I took this and added 61, I'd get here. How can I find the next one? Add 61. Do you guys kind of follow? If I added class width, I'd get, if I added 61, the next midpoint is going to be 123. 223. 213. Because this is just plus 61, plus 61. All right? Okay, so you guys take your word bank, fill out the rest of the words and the rest of your front sheet. Fill them in. You have 60 seconds. 2 minutes. 2 minutes. Do it in 2 minutes.